Hello everyone. My name is Shayasar Kumar and I am from Sri Venkateswara College of Engineering. I am studying in third semester under Department of Data Science. In this video, we are going to be learning about data structures. So what are data structures? Data structures are essential components in computer science and programming. They provide a way to organize, store and manipulate data efficiently. One of the fundamental aspects of data structures is their ability to optimize the performance of algorithms, making them indispensable in various applications, from databases to software development. When designing and implementing data structures, it's crucial to consider factors such as time complexity, space complexity, and the specific requirements of the problem at hand. Different types of data structures, including arrays, linked lists, stacks, queues, trees, and graphs, each have their unique characteristics and real world use cases. Without further ado, let's begin. Binary tree. So, what's the definition of a binary tree? A binary tree is a data structure in which each node has at most two children, referred to as the right child and the left child. It consists of a root node, which is the topmost node, and branching out into subtrees, where each subtree is also a binary tree. Let's see the concept of traversal. There are several ways to traverse a binary tree, including in-order, pre-order, post-order, and level-order traversal. Each traversal method provides a unique way to access and process the nodes of the tree. What are the applications for binary tree? Binary trees are extensively used in computer science with applications in data storage, sorting algorithms, expression parsing, and more. They provide efficient ways to organize and retrieve data. Now let's see binary tree traversals in detail. Pre-order traversal. In pre-order traversal, the root node is visited first, followed by the left subtree and then the right subtree. It is represented as NLR, node left right, and is commonly used to create a copy of the tree. In order traversal. In order traversal, the left subtree is visited first, then the root node, and finally the right subtree. It is represented as LNR, left node right, and is commonly used for binary search trees to retrieve the elements in non-decreasing order. Post-order traversal. In post-order traversal, the left subtree is visited first, then the right subtree, and finally the root node. It is represented as LRN, left-right node, and is commonly used to delete the tree. Now let's see graphs. The first concept in graph is node. In a graph, a node, also called a vertex, represents an entity, such as a person, place, or object. Each node can have unique identifier and may contain additional information or attributes. Edge. Edges are the connection between nodes in a graph, representing the relationships or interactions between the entities they represent. An edge can have a direction, in the case of a directed graph, or be undirected. Connectivity. Connectivity in a graph refers to the presence and nature of paths between nodes. It can be used to determine if there is a path between two specific nodes or to assess the overall connectedness of the graph. Let's see what a directed graph is. So the definition of the directed graph goes something like this. A directed graph, also known as a digraph, is a graph made up of a set of vertices connected by edges where the edges have a specific direction. This means that the relationship between vertices is one way, and each edge has a defined direction from one vertex to another. Directed graph can also be used to model various real-world scenarios, such as social networks, website links, and transportation systems. What are the applications of the directed graph? Directed graphs are widely used in computer science, engineering, and other fields. They are particularly useful in modeling processes with specific flow directions, such as data flow in computer programs, task dependencies in project management, and information propagation in computer networks, in communication networks. Additionally, directed graphs play a crucial role in representing and solving problems in the areas of logistics, scheduling, and optimization. Traversal. Traversal in a directed graph involves visiting all the vertices and edges in a specific order. Common traversal methods include depth first search and breadth first search, commonly referred to as DFS and BFS respectively. These algorithms are used to analyze and navigate through directed graphs, making them essential tools for tasks like finding the shortest path, detecting cycles, and evaluating network workflows. Undirected graph. What are some features of undirected graph? Let's see. Connectivity. In an undirected graph, each edge represents a two-way connection between two vertices. This connectivity allows for the modeling of symmetric relationships between objects or entities, making it a powerful tool in various real-world scenarios. Cycles. Undirected graphs can form cycles where a sequence of edges connects a vertex back to itself. Understanding and identifying cycles in these graphs is crucial in fields like telecommunications and transport planning. Network analysis. The concept of undirected graphs is fundamental to network analysis. It facilitates the study of interconnected systems such as social networks, communication networks, and biological networks, providing insights into patterns of interaction and structure. Planarity. These graphs are also studied in the context of planarity, that is, determining whether the edges and vertices can be embedded in the plane without any edges crossing. This has application in circuit design and map representation. Now let's see what a complete graph is. The complete graph has three things: interconnected nodes, symmetric relationships, and maximum edges. What are interconnected nodes? A complete graph consists of a set of nodes where each node is connected to every other node in the graph. This interconnectedness represents the concept of a fully connected network, where every pair of distinct vertices is connected by a unique edge. Symmetric relationships. In a complete graph, the edges between nodes are symmetric, meaning that the relationship between any two nodes is bidirectional. This symmetry implies a mutual connection and equal interaction between all the nodes, fostering a sense of unity and mutual influence. Maximum edges. With n vertices in a complete graph, the maximum possible number of edges is given by the formula n into n minus 1 divided by 2. This represents the highest level of connectivity and interaction, making complete graphs valuable in modeling scenarios that require maximum interaction among the elements. Let's see what a subgraph is. A subgraph refers to a part of a larger graph that contains a subset of the original graph's vertices and edges. The main graph serves as the overarching structure, while the subset represents a smaller connected part within the graph. The connection or edges within the subset contribute to the overall complexity and interconnectivity of the subgraph. Understanding subgraphs is crucial in analyzing specific components and relationships within a larger graph, allowing for more targeted insights into complex data structures and relationships. Now let's see what's a path in a graph. Shortest path. When considering the concept of paths in a graph, it's important to highlight the concept of the shortest path. The shortest path between two nodes in a graph is defined as the path with the minimum cost or distance. This is a fundamental concept in graph theory and has numerous applications, including in transportation networks, computer networks, and optimization problems. Weighted graphs. Path in a weighted graph can also be further categorized into weighted and unweighted paths. In an unweighted graph, each edge has a numerical weight assigned to it, and the path's cost is determined by the sum of the weights of the edges as it traverses. Understanding the different types of paths in weighted graphs is essential for various algorithms used in real world problems. Eulerian path. An Eulerian path is a trial in a graph that visits every edge exactly once. Such paths are of great significance in graph theory and have applications in circuit design, DNA sequencing, and network analysis. Understanding the characteristics and implications of Eulerian path enriches the understanding of paths in a graph. Now let's see what a cycle in a graph is. The definition goes something like this. A cycle in a graph is a path that starts and ends at the same vertex, with no repeated vertices except for the start and end vertices. The characteristics. Cycles can exist in both directed and undirected graphs. Importance. Cycles are significant in identifying connectivity and detecting circuit-like behavior in graphs. In graph theory, a cycle is an essential concept that signifies a closed path within a graph. It is crucial to understand the properties and implications of cycles in both directed and undirected graphs, as they play a vital role in various algorithmic applications and network analysis. Detecting cycles aids in uncovering patterns of connectivity and facilitates the identification of structural characteristics within a graph. Moreover, the presence or absence of cycles influences the overall behavior and functionality of graphs, making it fundamental aspect of graph theory and computational analysis. Thank you. If you have enjoyed watching this video, like and share it. And if you like to have more content like this, subscribe to my channel.